All right, I had this up yesterday. You have 28 questions in your packet, many of which we're getting done right now. So if all those get done, there is an extra review posted on Classroom. All right, that's all multiple choice. So if some of you guys struggle with multiple choice sometimes on a test for me, that might be a good place too to prepare is that extra review because that's all multiple choice. All right, and I'll be after school today. Any questions you're coming up with that you want to ask individually before I start here? Okay, here we go. Same thing as yesterday here. That's what we did yesterday. 15, here we go. Let's start with 15. Figure we didn't talk about yesterday, isosceles trapezoid. I'll let you guys mark your diagram with the givens. Tells you in the givens AD and DE equal, so make sure that's marked AD and DE. I'm starting you out with angle D 110 and somehow got to get to angle AD AED. Angle AED. All right, it's an isosceles trapezoid. Those sides are parallel. Those segments are congruent. Make sure you know what angle we're looking for here, AED. So anybody we'll start with somebody here. Just tell me any angles that you know are true based on it's an isosceles trapezoid or DE and DA are equal here. All right, anywhere you want me to go with angles. All right, I'm not concerned about sides here. We're only talking about angles. So any angles you're confident in, you want me to label up here. Any angles you're confident in. Here we go, Bailey.
Angle DCB would also be one.
Great job. This is an isosceles trapezoid. The property's right in front of you right now. Base angles are equal. So angle C is also 110. Angle C is 110. And just a reminder what angle we're trying to get to here. AED, this one right here. I got to get to that angle. Look at what you marked on your diagram. Don't overlook it. Don't just focus on the isosceles trapezoid. Look at those two sides you marked congruent. All right, here we go. Anywhere else we want to go? Anywhere else? Stephanie, anywhere else? Okay, I like that. I'll keep labeling. Angle B is 70 because those are same side interior angles, which makes them supplementary. Yep. Angle B is 70. We're getting there. All right, I like that you guys know why you're labeling these angles. A certain degree measure, you're using your properties, which I'm fine with. Let's keep going. Anything else you want to tell me about here, Lily?
The entirety of angle A is 70, but it's being bisected. So.
How do you know that? I agree with your statement, Lily, that angle A, all of angle A is 70. I agree with that, but I don't know why it's bisected. Okay? All right, I don't see anything up here that says it's being bisected, so it does end up being that way, but I don't see anything up here telling me it's bisected, right? Okay, let's keep going. You guys are doing a nice job here, labeling those angles of a trapezoid. Still got to get to that one here. Isn't there a reason maybe that they told us those two were equal to each other, maybe? All right, there's got to be a reason why they told me DE and AD were equal to each other. Let's hit on that right now. Micaiah, what type of triangle is AED?
Isosceles.
Oh, it's isosceles. What's across from those sides? Congruent angles. Everyone see that? All right, this triangle here is isosceles. So across from those sides are congruent angles, including the one I'm being asked for in the problem. So right now I have 180 degrees in that triangle. One angle was 110, right? So that leaves me with 140 Nope, sorry, just leaves me with 70. And we were just told it's isosceles, so those angles are equal. Divided by 2, each angle, 35. Each angle, 35. All right, real nice job, though. Anybody I called on there, real nice job labeling those angles using your properties. Real nice. That's what I'm looking for. All right, let's go to 22. 22, let's talk about interior, exterior angles. Can you add in a word here? Because I can't do the problem unless I add this word in. This is a regular pentagon. All right, regular pentagon. All the angles and sides are congruent. I can't do this problem without knowing it's regular. Let me start here. So we start on the right note. Pentagon, how many sides? Pentagon. Pentagon. Hey, look at that. Never mind. That was going to be a good one, but never mind either. Henry, Pentagon? 5 sides, yep. 5 sides, that's important in the problem because it has 5 interior angles and it's got 5 exterior. I just want to know one though. You know what? I'm going to start with the exterior angle. I'm going to start with finding one exterior angle. Why am I going to start with an exterior? I already know something about them. Micaiah, going back to you. I know there's 5 of them, but I do know they all add up to what? Darn right. So that's why I'm starting with the exterior. I know all 5 add up to 360, and they're all the same because they're regular. So I'm going to divide that bad boy by 5. So everyone does the calculation. That exterior, 72 degrees. All right. Still on the hook for an interior, though. A couple ways you could get there. Okay, how are you going to get to the interior? Because there's 2 different ways. I don't care how you get there. There's 2 different ways. How do I get to the interior angle? All right, good job, Vinny. All right, Alyssa, your show here. How do I get to the interior?
180 times 5 minus 2.
Okay, so if I do 180 times 5 minus 2, what's that going to give me?
180 times 3.
Okay, all right, you got me there. So that's going to be 540, I believe. No, 540?
Yeah.
All right, is that one angle, though? What did you just find me? You're getting there. What did you just find me? All of them. So what do I want to do with your 540?
Divide them by 5.
Yeah, that's fine. Yep. So you should end up with 108 degrees. So there's one. That's the one way. The other way, what do I know about an interior and exterior? They're always supplementary. So that's the other way you could have gotten there. Either way, good. Yep. I just don't want you to give me 540 though. That's what they all add up to. I was only looking for one. Okay, good with 22. All right, let's go deep in your packet for me. There's a couple things I know will be on the test tomorrow we have not spoken about since before break, so let's go to 29. All right, we got just a trapezoid. Notice I did not put the word isosceles in front. Just trapezoid. That's it. Not isosceles, just a trapezoid. Mid-segment MQ. All right, so let's start right there. Mid-segment. 16y plus 1, the mid-segment. And I know this is not on your properties, so we're going to have to dig deep. Anybody remember how to find the length of a mid-segment? There was a little fact I had given you, how to find the length of that mid. This mid-segment is the same as doing what? Go ahead, Zoli.
Adding the bottom and top section.
The bases, yep.
The bases and dividing them by half.
Okay, so the mid-segment, here we go. Mid-segment is equal to the sum of the bases, 12y plus 1 and 18y plus 6, and taking half of that. It's half. Mid-segment is equal to half the sum of the bases. So that's how we're going to find y anyway. So we'll solve that for y and then worry about x. Mid-segment, half the sum of the bases. So let's clean this up. Keep going. I'll stop there. You guys can keep going. You can distribute the 1/2. If you don't want to distribute the 1/2 and want to get rid of it right away, you can multiply both sides by 2. But your call. Two and a half. Looking good. 2.5. 2.5. Let me know any issues getting the 2.5 before we find x. All right, you ready for x? You have 3 angles that are labeled with x here. 12x minus 4, 7x plus 13, and the 6x. Only 2 of them have a relationship, though. And remember, it's only a trapezoid. That's all I know, that the bases are parallel. That's all I know. All right, if I said I didn't say isosceles, so base angles aren't equal. So out of these 3 angles up here, which 2 have the relationship? And what is the relationship? All right, because only 2 of them are related. It's not isosceles, it's just a trapezoid. So only 2 of these have a relationship. And we just went over them, and we actually just went over this in the other trapezoid problem at the beginning of class. All right, here we go. Dylan, you know which ones are related?
Angle T and angle P.
Okay, so here we go. 12x minus 4 and the 7x plus 13 are related. How? I just wrote them down. Go, you want to keep going, Dylan?
They're supplementary.
Their same side interior makes them supplementary. Perfect. Hey, I changed this and I put it's isosceles trapezoid. Now you can set angle P equal to angle A, but not until it's isosceles. All right, this was not isosceles, so I just had same side interior angle supplementary. Good. Gaining some confidence for tomorrow. And make sure you get 9 out of that. 9. And the last one I'm going to do with you, because we haven't talked about this figure at all in our review, go right to number 30, the old kite. We have not talked about the kite. And reminder, I'm promising you all figures will be asked tomorrow. I don't know how many questions for each, but all figures will be asked tomorrow. So look at your properties of a kite on your Chromebooks. See if you can do anything else with what I gave you. RC is 10. BD 48. What's CD? So what do I know about a kite that may help me out? And that may, I don't want to say help you out, but maybe you can label your diagram a little better. Put a little more detail on that bad boy. So what else do you see there for a kite that might help you out?
Is AC a diagonal?
What's that?
Is AC a diagonal?
AC and BD are both diagonals. Remember, diagonal always connects two non-consecutive vertices. So both diagonals are drawn in this kite. So that should help you out big time. All right, let me start. How about a property? Give me a property that might help us out here. Property that might help us out of a kite. Choo choo, Brendan. Any property of a kite might help us.
The diagonals are perpendicular.
I'll take that because now at R I have right angles. I'll take that, definitely. That might help me out. One more property, though. That's going to help me, definitely. Something else about our diagonals up here. Going. Alyssa, back to you.
Diagonals bisect each other.
They don't bisect each other.
One diagonal.
The longer one bisects the shorter. All right, remember, they don't bisect each other. Longer bisects the shorter. So this shorter one of 48 is getting bisected into 24 and 24. That will help me now. I think now I'm on my way. Why? What type of triangle is RCD? A right triangle. I know two sides. How do I find the third? There it is. Pythagorean theorem. Where are the 10 and 24 going here? A, B, C? Where should the 10 and the 24 go here? A and B, right? Those are the two sides that make up the right angle. 10 squared. Make sure, hey, maybe tomorrow I flip it on you. Maybe the 24 is over on the hypotenuse, so you plug it in for C. Be careful. All right, A and B are the sides that make up the right angle, the legs. CD is your hypotenuse across from the right angle. Make sure at the very end you take the square root. And hopefully we got out 26. Those are the ones I wanted to go over with you. I'm going to save you some frustration because I'm not going to ask these tomorrow. You can cross off numbers 25 and 26. Those two proofs, 25 and 26. I will not ask you in a statement's reasons to prove anything tomorrow. I'll let you know right now. Tomorrow, the statement's reason one is given it's this figure, prove the triangle's congruent or maybe CP/CTC after. All right, so I'm going to give you it's one of the quadrilaterals we talked about. Prove triangles congruent or CP/CTC. I didn't realize either you have the answers in the back of your packet, so I thought I didn't provide those. So you have the answers in the back of your packet. If you get everything done, extra review up on Classroom. So let's get plenty to do here, plenty to practice. Let's get rolling.